Today, I'd like to present the most helpful parts from the commonly recommended book, Clean Code by Robert C. Martin. So please keep in mind that these are the opinions of the author and his fellows in the industry, and it may not apply in all cases. And additionally, I have removed a lot of the Java-specific references, mainly because it doesn't apply to me, and I think it doesn't apply to most of the folks on the team. So I will start with my three main takeaways. We'll define clean code and cover widely applicable foundational items, and then we will also take a look at concepts to practice. And finally, we'll take a look at a few common code smells. So for my three main takeaways, the first is that writing code is a process. You will draft it, refine it, and repeat, and it takes practice. And what matters ultimately is that your team agrees on standards and sticks to them. It doesn't matter if you use everything in the book or nothing in the book. It doesn't matter as long as everyone is doing the same thing. And finally, it is everyone's responsibility to keep a code base clean. Clean code is beautiful and it embodies a level of discipline. Business needs and team members will inevitably change, so it's important to solve problems using meaningful code. I've heard the broken windows metaphor elsewhere, but I really like the application here, so it goes. A building with broken windows looks like nobody cares about it, so other people stop caring. They allow more windows to become broken, and eventually they actively break them. They despoil the facade with graffiti and allow garbage to collect. One broken window starts the process towards decay. In addition, here are some insights from other industry experts. The most meaningful to me is that it does exactly what you would expect. I also really appreciate the well-tested, efficient, and no surprises interpretations. And there's a lot more detail here inside the book. These are just really succinct and concise pulls from other people's responses. So what else? Without developer discipline, new features will slow over time, and as the mess grows, so does the time needed for the code base. New team members must wade through to make any impact, and clean code requires a little bit of pushback within reason for higher quality output, mainly because others rely on our honest estimations, and historically we won't return to messy code unless we have to. So it's best to take time to care for the code base whenever possible. So inside the book, we talk a little bit about the Boy Scout rule, which is essentially leave the campground better than you found it. And this applies to the code base, documentation, tests, whatever you see that can be improved even slightly. It's best to leave it better than you found it. So let's move on to some of those foundational aspects. So let's talk about names. What's in a name? A lot of meaning, actually. So we will talk briefly about variable names and class names. For variable names, you want them to be pronounceable. So a quote from the book is that humans are good at words, and if you can't pronounce it, you can't discuss it without sounding like an idiot, which is factual. We also want our variable names to be searchable. So for instance, if you're using something like a static number or something that is hard to read, like a regex expression or something along those lines, for instance, one thing that we've done is a valid E164 format regex is the name of our variable instead of a complicated regex pattern. You can also, or you should also use intention revealing and meaningful distinction names. So some things that might be included are rather than using something like ID, we could use something like service X customer ID so that we know exactly what this ID is used for, what does it pertain to, and it's relevant to what we're reading. As far as avoiding, we want to avoid disinformation. So if a variable is a number, it should not be named money string, for example. We want to avoid abbreviations, unnecessarily long names, or similar spelling. We also want to avoid characters that look alike. So something like a lowercase l and an uppercase I, or the number 0 and an uppercase O, when they're near each other, they look very similar. We also want to avoid number series naming. A1 and A2 mean just about nothing to me if I'm reading a program. So something that makes sense rather than just a number series. We also want to avoid noise words, encodings, and mental mappings that really just obscure understanding. For class names, we want to use verbs or verb phrases for methods. Methods are taking action, so that makes sense. We want to use one word per concept, and whenever possible, we want to use solution names. Mainly, this pertains to common programming terms that they would understand. Whenever that's not possible and there's no programmer ease, if you will, it is suggested to use problem domain names. So name your classes based on the context of the problem you're solving. And in using both of those, you will also rely on adding meaningful context. We want to avoid noun phrases, adding too much context, and especially because most teams, especially our team, is globally distributed, we want to avoid cleverness, puns, and slang. It almost never lands between one and the other, and oftentimes you may have something that makes sense in one country or one continent but doesn't in another, so it's best just to avoid that whenever possible. The first rule of functions is that they should be small. The second rule of functions is that they should be smaller than that. This is a quote from the book, but I do really like that concept. They should only do one thing. It should be readable. It should have descriptive names and minimal arguments. And functions should also either do something or answer something, but not both. As far as comments go, there are many viewpoints, and everyone has a school of thought. Ultimately, as I said earlier, the ideal situation is that you just adopt the team's pattern. But the best advice that I have heard so far about when a comment should be used or why is essentially to explain why you made a business decision and not what the code is doing. And additionally, you should delete dead code. So if you're commenting out your code, just delete it. You can always come back to it later, or there is version control for a reason. So a few bad comment examples might include personal journaling and notes, position markers, or commented out code or HTML comments. If it's not useful to everyone, just get rid of it. But I would really like to focus on the good comments, which could include something like a legal comment, something that's informative and useful, something that adds clarification or an explanation of intent of what you're doing in this little section. Something that also amplifies the importance of maybe a particular function or something that you're doing. And along those lines, something that also warns of consequences. So if you change this, we might have XYZ consequences would be helpful. And then to-dos are also great comment options to leave within reason. If you're making a ton of them, you may as well just make tickets to address changes rather than just adding in a bunch of to-dos. So quick formatting tips. Vertical spacing is really helpful to reduce scrolling of a developer. And the vertical openness can also add concept breaking so that it makes it easier to read and understand what's happening. And typically you want to order the concepts from high priority to low priority. Again, keeping the code more readable. For horizontal spacing, openness can also add to understanding here, for instance, with hierarchical indentation. It just helps everything be more readable. So a quote from the book reads, "So too, being able to recognize clean code from dirty code does not mean that we know how to write clean code." So with that said, I've gathered a few things to allow us to put them into practice. So these are more interesting or applicable concepts and suggestions that we can try out. So the first thing is to abstract and hide data to reduce manipulation and exposure. Bob Martin also recommends preferencing exceptions over error handling because technically error handling is another thing being done with inside a function. And we can also provide context for more informative error messages, and we can wrap third-party APIs to handle errors from the source. As far as third parties, learning about the boundaries early on is really helpful. So we can read the documentation, test and explore, and we can also build learning tests, which as a bonus can help us identify external API changes really early on. We can wrap third-party code so we can control what is used and reduce the affected code when a change happens that we ultimately can't control. And taking this approach can also help us to define the interface we want when the unknown is present, because we can depend on code we can control rather than code we can't. And as I mentioned earlier, it's almost inevitable to avoid a third-party change. As far as unit tests are concerned, tests are just as important to keep clean. We want them small, we want them readable, because ultimately they reduce the fear of bigger change and they can help us catch potential issues. And it can even act as documentation when done well. It doesn't need to be as performant as production, but definitely small and readable is ideal. It should cover one concept per test, and ideally only one or as few as possible assertions per test for easier debugging. The first rules here, excuse me, is that tests should be fast so they can be run often. They should be independent so that it's easier to diagnose issues. They should be repeatable in any environment. They should be self-validating so that you have a Boolean to tell you whether or not it passed. And they should be timely, meaning that you should write it alongside your new code. And I won't go through them, but the 3 laws of TDD are here and present within the book if you're curious. So just like functions, classes should be small, and they should be smaller than that. We want to try to avoid a God class that does all of the things and instead follow the single responsibility principle. We should isolate classes from external change as much as possible and add functionality only when it's needed. They should be organized with variables at the top, followed by items of most important at the top and least important towards the bottom. For systems, we can turn to an example from the book. A hotel is built by a set of construction and engineering teams, whereas a hotel is used by regular people on vacations or on business trips. Functions are entirely independent and should also be built and used in the same way as this example. So, like tests and compiled code should remain separate, just to sort of bring that home. Dependencies should head in a direction away from main or from the original object, and if you implement only what's needed today, we can be agile and scale when we need to, and we can grow our sophistication over time. The quote here kind of highlights that at times it's better to wait to make a decision so that you can be the most informed possible. You can also use domain-specific language, which helps a system read like a document from an expert, which does help to reduce translation issues you might run into. And finally, I have some common code smells, so I will cover a few that stood out to me, but if you have time and you want to look deeper later, I have a large table here of different ideas that came from the book. So for comments, an obsolete comment is confusing and misleads other developers. So if you see a comment that no longer is relevant or doesn't make sense, delete it. Under the environment, tests should only need one step. They should be super easy and run often so that everyone can stay on track. Under functions, too many arguments are hard to decipher, and when you need a lot of input data, so for instance, maybe more than 2 arguments, using an object is recommended. Names should describe side effects. I mentioned earlier that clean code should do exactly what you expect, and when you read it, you should generally know what it's doing or what it should be doing. And for tests, you don't want to skip even the trivial tests because testing every little detail adds clarity and ensures that things won't be missed, no matter how small. There were quite a few general code smells, so I've got another table here, and I'll just pull out a few of my favorite ones as well. So one is one we talked a little bit about earlier, is replacing magic numbers with named constants. So going back to that regex pattern example, or like if you have, for instance, something that should be hard-coded in multiple places, even in one place, setting it as a variable name is better than having some like unknown, what is this variable doing? It just helps add clarity for the reader. And it gives it clarity for you and for any devs who might come behind you. Duplication is something that I am trying to hone myself. Basically trying to recognize when something similar happens in multiple places so we can refactor it and handle it in one way. Finally, clutter and dead code are technically 2 separate ones, but they're very similar. If it's not being used or it's not relevant, remove it. So whether that's comments, whether that's code that's not being used anymore, just remove it if it's not being used. So to sum all this up, here's a quick rundown of the most important pieces, TLDR if you will. So you want to run all the tests. They should be easy. Refactoring is incremental. Write dirty code and then clean it up. Eliminate duplication and ensure clear expressiveness for others. Choose good names, keep functions and classes small but not too small, and use standard nomenclature and programming patterns, and practice makes perfect. Thank you um, for watching, for listening, and if you have any questions, comments, or concerns, please feel free to let me know.